In the final part of the question, it talks about the chemist was repeating this experiment and then making one change but using the same initial amount of CH4. So what we need to do is think about what happens to Kc under these conditions. We're only allowed to use the word greater, smaller and same. And what I'm going to do is replace those with the greater than, the less than and the equal sign just to save writing. Now the container is heated. Now Kc is affected by temperature, and the way that Kc is affected we can tell by the sign of the enthalpy change of the reaction. Now if the enthalpy change of the reaction is positive, we know that when we heat the container, what we're going to tend to do by Le Chatelier's principle is increase the yield of the endothermic reaction. So the endothermic reaction will momentarily happen quicker because that reaction is the one that absorbs heat, so it minimises the change. So if we look at our expression for Kc, if we're increasing the concentration of the product, then we're going to increase the size of this fraction, and so Kc will become larger. Now let's work across what happens to the equilibrium amount of C2H2. We've just discussed that what's going to happen there is that the amount of that will increase by Le Chatelier's principle, so that's going to be greater. And the initial rate of reaction will also increase because initial rate of reaction is always increasing with temperature. Now a smaller container is used, and this is significant because these are all gas phase reactants, and so what is going to happen is that the pressure will increase. The pressure increases. So in this situation here, what is going to happen to Kc? Well, Kc is a constant unless the temperature is increased. So we know that Kc stays the same. The equilibrium amount of C2H2. Now this is where we need to think about Le Chatelier's principle. So what we've got in this reaction here is we've essentially got 2 moles or 2 molecules of gas, and over here we've got 4 molecules of gas. So if we increase the pressure, we will increase the yield of the reaction which produces the fewest number of moles in order to counter that change. And what will therefore happen is that the concentration of CH4 will increase. And so we're actually going to have less C2H2 at equilibrium. The initial rate of reaction is just going to increase with pressure because there's going to be more frequent collisions, and therefore that will be greater. A catalyst is added to the CH4 at the start. Catalysts do not affect the position of equilibrium, they do not affect Kc at all, and therefore Kc stays the same, as they don't affect the position of the equilibrium because they increase the forward and backward rates equally. This will remain the same, and then they do increase, however, the initial rate of reaction. The final part of the question is a simple knowledge-based question. Improving the atomic economy, it's useful to make use of hydrogen. What can they use hydrogen for? Now be careful because they've told you it can be used in the extraction of some metals from the ore, so don't put that down here. Other uses, there are many. The most common ones we meet at A2 would be in fuel cells. Now don't put fuel cells for vehicles and fuel cells for something else. Fuel cells would be one. There are many other ones, so things like saturation of alkenes, hydrogenation of alkenes, manufacture of ammonia, I will put down here the Haber process. But there are a number of other uses, and that's going to be a case of just learning some uses of hydrogen. It's quite commonly asked.